Hello everyone. As usual, this is Anirudh over here. I am a student of IIT Kharagpur, currently a third year undergraduate in the Department of Computer Science and Engineering and Rodents Media course. I'm from Chennai, right? That's in Tamil Nadu. So today we'll be dealing with chapter matrices. That is chapter number 3 of class 12 NCERT Maths, right? This chapter, what you're going to deal with is the concept of a matrix, which is an abstract mathematical construct, which just groups data, right? It's a form of grouping data where you get to deal with classes of data which are pretty similar to each other and which behave in certain different ways that is data. Where it's used for is when you have something like say you have this, right? You have some sort of a class which is associated with one thing, right? For example, here we have the example that Radha has 15 notebooks and 6 pens. So you represent it as a class of 15 and 6, which is a matrix, right? And so which it can also be represented as 615. You just need to know what and where you represent it because it's it's abstract and it's basic English, right? And if you have something like Radha, Faiza, Simran, these are 3 people belonging to the same class of people, right? These are 3 things belonging to the same class of notebooks. That is, this is the number of notebooks and this is the number of pens. So basically what you can do is you can represent it as 3 rows that of notebooks and pens, right? 15, 6, 10, 2 and 13, 5. And so you can represent it as a matrix in this, right? Where you group like data and in terms which can be used to further simplify it or further work on it easily, right? You can also represent it in this form where you have notebooks and pens over here while you have the 3 people over here. So it's 15, 6 in a column, 10, 2 in a column, 35 in a column. Right? Both are matrices. Both are perfectly valid examples of matrices. And the way you actually represent it depends on what you want to do with it, right? That's how you choose. Right? So basically, a formal definition of a matrix is an ordered rectangular array of numbers and functions. These numbers and functions are called the elements or the entries of the matrix. Right? Matrix elements need not be just numbers, they can also be functions like 1 plus x, cos x, sin x plus 2, tan x, or some kind of a root of root log mod x, whatever. Right? It can do whatever function. All right. And you have this term that is very important, right? The order of a matrix. So if you have if a matrix has m rows and n columns, then it is a matrix of order m cross, right? The number of rows into the number of columns. So basically, the last index over here, that is the nth row or the mth row times the nth column, right? That is called the order of a matrix, right? It's always represented in this form, and m cross n, right? You can't just multiply it and say that it is of order 3 into 2, that's 6. You can't do that. It's 3 cross 2, and you generally read it as a cross, not an into. So yeah, but that the way you pronounce it depends, right? And then you have these notes. That is this notation that this is the matrix variable is equal to the matrix of Aij of the order m cross n, right? Which means that these elements Aij are expanded to form a matrix of m cross n elements, right? And we deal with only matrices whose elements are real numbers or real functions, right? We don't deal with imaginary numbers or complex functions, nothing of that sort. Right? And you also see that another example of a matrix, a real world matrix, is a point in a plane, right? Or when you deal with vectors, you can also represent it as a matrix of vectors, a plane vector, right? Not a plane vector, but a matrix of 2 vectors of I and j, right? Or I, j, and k, as this equation calls for, right? And so we come to the examples. Right? And then you have the different types of matrices, right? The different types of matrices are basically a column, a row matrix, a square matrix, a diagonal, scalar, identity matrix, and a zero matrix. Right? So what a column matrix is basically a matrix which has a column or has an order M cross 1, right? In general, a row matrix is the transpose of this, or is basically a matrix which has one row, which has one row and many columns. That is, it has an order 1 cross n, right? A square matrix, on the other hand, is a matrix where the number of rows is equal to the number of columns, or it has an order m cross m or n cross n, whatever, right? Or you can say that it is a square matrix of order m. It means that the matrix is of order m cross n, right? This and this are these are equivalent entities. All right. Then you have the diagonal matrix, which is basically if the non-zero elements only occupy the major diagonal, right? That is, all the other elements, all the other non-diagonal elements are always zero, right? And it's always a square matrix. If it's not a square matrix, it can't be diagonal. All right. So for diagonal, basically you have three conditions to be taken. That is, A is a square matrix. B, the non-zero elements occupy the diagonals, right? Which leads to C, that is, all the other elements are zero. Scalar matrix is a diagonal matrix which has all elements to be equal, right? So basically, you can remove this and say that C is equal to root 3 times 1 0 0 0 1 0 0 0 1, right? Basically, a scalar matrix is a constant, a scalar times the identity matrix, right? That is basically the definition of a scalar matrix. All right. And the identity matrix is basically a square matrix in which all the elements of the diagonal are 1 and the rest are all 0, right? Which is basically 1 1 1 and zeros otherwise. And for 4 cross 4, it is basically 1 1 1 1 zeros otherwise, right? This is basically I4. There is this notation which is basically IN, which is an identity matrix of order, right? Should not get confused when I use this kind of a representation. It basically means an identity matrix of order. Similarly, ON is basically a zero matrix of order n. Zero mat of order n, right? And a zero matrix is basically a matrix where every element is zero, right? And it's a square matrix, right? Okay, wait, it doesn't need to be a square matrix. Okay, fine. So a matrix is said to be zero, or a null matrix if all its elements are zero, right? This is a zero square. It's a square matrix of order n. All right. Now then you go to equality, where if two matrices are equal, then each and every element in the same place are equal, right? So basically, if A is Aij and B is Bij, then Aij is equal to Bij for every Inj, right? That is the definition of an equality of a matrix, right? And since we have completed the basic theory and principles behind a matrix, go to assess, right? Further on in this chapter, you get to learn what the different operations on a matrix are and how you deal with them. And I think you also deal with transposes and properties of a matrix, right? Right. You deal with powers and the other different types of matrices, that is symmetry, skew symmetry, and all that, right? And invertibility. Fine. So we deal with, we go to exercise 3.1. This is 3.1, right? 3.1, question number 1. In the matrix A equals matrix of 2 5 19 minus 7, 35 minus 2, 5 by 2, 12. This is root 3, 1, minus 5, and 17. Right? First of all, you can see this. This has 1, 2, 3 rows and 1, 2, 3, 4 columns, right? So the order of the matrix is 3 cross 4. Correct. First, right? Second, you have fine, okay. So this is this, and then you can see that this is a normal matrix. It's not this is not square. This is not a diagonal matrix. This is not identity. This is not a scalar matrix. Nothing of the sort. This is a normal matrix, right? And so you have this is also not a zero matrix. And so you don't have any special thing else further going to say. So just proceed with the question, right? First, the order of the matrix is 3 cross 4. I already proved it to you, right? Second, you have the number of elements. That is basically you multiply the order and you get the number of elements inside the matrix, right? 0 is also an element. Do not forget, right? Only and only if you have something of a null value, which is basically an empty hole inside the matrix, only and only then will you say that there is no element inside. Otherwise, the matrix, even if the value is 0, that 0 is going to be an element, right? So the number of elements in this matrix is basically 12, right? Or you can count, of course. But you can't do that when you have a very high order like 500 plus 500. But you can do it if you have like 3 plus 4. That's easy. Right? And 3 is write the elements A13. Write the elements A13, A21, A33, A24, A23. Right? So first of all, A13, right? Aij is basically the element in the ith j and the jth column. Right? So A13 is basically this row and this column, that's 19. Right? Then going to A21, right? A21 is basically the second row and the first column, which is 35. Similarly, I just write the 3 more elements, right? Now we need A33, right? A33 is basically over here and over here, that's -5. So we have A33 being -5, right? Minus this is 5. Right. Similarly, A24 is going to be over here, it's going to be over here, well, right? And A23 is going to be this. That's 5, right? That finishes the first question. Going to question number 2. The matrix has 24 elements. What are the possible orders you can have? Right? First things first, note that if you have 24 elements, you can only have a matrix which has exactly 24 elements inside and not one less or one more, right? If you have something of this sort, each dash is an element, right? So you have 6, 6, 6, 6. That is, this is a possible matrix, but you can have one over here. You can't have 6, 6, 6, 7 and say that this is basically a null value, so I'm not counting this and it has only 24 elements. You can't say that, right? Because you're considering a real valued, real function matrices, right? So if you have a 24 element matrix, then the possible orders you can have are basically the factors of 24, right? It's 1 cross 24. It is 2 cross 12. It is 3 cross 8. It is 4 cross 6. Then it is 6 cross 4. Wait, just 4 cross 6. And then it is 6 cross 4. It is 8 cross 3. It is 12 cross 2. And it is 24 cross 4. Right? Can have 8 possible orders. And any one of these orders are basically valid. Right? So these are the possible orders of a 24 element matrix. And what if it has 13 elements? If it has 13 elements, the only 2 possible orders are 1 cross 13 and 13 cross 4. Right? Because 13 is prime. So it has only 2 factors, that's 1 and 13. Alright. So a 13 element matrix is going to be either a row matrix or a column matrix. And yeah, that's basically it. Okay, there's no other information to be given. That's question number 2. 3 says that if a matrix has 18 elements, what are the possible orders it can have? This is basically the same as what we did previously, right? So you have to find the factors of 18. That is 1, then you have 2, then you have 3. You don't have 4, you don't have 5, and so the next is 6. And so we are going to deal with a repeat of the 3 aforementioned orders, right? The 3 aforementioned factors. This is 9 into 2, and it is 18 into 1. Right? So you can have 6 possible orders. Right? What if it has 5 elements? Again, same as previously, you can have either a row matrix or you can have a column matrix. No other possible values, right? That is question number 3. Then question number 4. Construct a 2 cross 2 matrix Aij whose elements are given by Aij equals 1. Aij is equal to I plus j the whole square divided by 2. Right? So you since you have a 2 cross 2 matrix, your A is going to look like for every for every subpart in this question, your A is basically going to look like A11. This is A21. This is A12, and this is A2. Right? A20. Right? This is going to be your A. Right? Since Aij is going to be I plus j the whole square divided by 2, you're going to have your matrix A is equal to a matrix of 1 plus 1 the whole square by 2. This is going to be 2 plus 1 the whole square by 2. This is going to be 1 plus 2 the whole square by 2. And this is going to be 2 plus 2 the whole square by 2. Right? Which is basically, this is 2 squared, that is 4. 4 by 2 is 2. This is 4 plus 1, 2 plus 1, 3 squared is 9. So it is going to be 4.5. The same over here because 2 plus 1 is 3. So you have this, again, this is going to be 4.5. And this is going to be 4 squared, 16 by 2, that is 8. Right? That is part 1. Part 2 has Aij is equal to I divided by j. Right? So you have A is equal to matrix of 1 by 1. This is going to be 2 by 1. This is going to be 1 by 2. And this is going to be 2 by 2. Right? Or which is basically 1 over here. This is going to be 0.5 and this is going to be 2. Alright. And then the third question. I just write it over here. Third question. Right? Third is basically Aij is equal to I plus 2j the whole square by 2. Right? So A is basically going to be equal to the matrix of 1 plus 2 the whole square by 2. This is going to be 1 comma 2. So it's going to be 1 plus 4 the whole square by 2. This is A21. That is going to be 2 plus 2 the whole square by 2. And this is going to be 2, 2. That's basically 2 plus 4 the whole square by 2. Right? Which is basically, this is 5. This 1 plus 2 is 3. 3 squared is 9 by 2. That is 4.5. Right? I just write it in decimals because that's easy. This is going to be 2 plus 2 the whole square, 2 plus 2, 4. 4 squared is 16. 16 by 2 is 8. Here it's going to be 1 plus 4. 5 squared is 25 by 2. That's 12.5. And you have 2 plus 4 being 6. 6 squared is 36. 36 by 2 is 18. Right? That is your reply. Alright. That completes the fourth question. Then going to question number 5. Construct a 3 cross 4 matrix whose elements are given by this. Right? So your A here is going to look like A11. It's going to be A12. It's going to be A13. It's going to be A14. Similarly, you're going to have A21. Here A31. And then this is A22. This is A32. It's going to be A23. 23. This is going to be A33. And then there is going to be A24. And there is going to be A3. Right? For the first subpart, you have Aij equaling half mod minus 3i plus j. Right? Since we have already done a question of this type over here, I'm going to directly proceed into the calculations without really arting that substituted. Right? And so I'm going to directly write out the matrix A without making the whole big substitution. Right? Basically, this is going to be half of minus 3 plus 1. This is going to be minus 1. This is half of minus 3 plus 2. That is going to be minus half, right? This is going to be minus 3 plus 3, that is 0. And this is going to be minus 3 plus 4, that is going to be half, right? Because it's minus 3 plus 4 divided by 2, right? And then you have, this is going to be minus 6 plus 1 by 2, that's minus 0.5, right? Because if you add 1 over here, you are basically subtracting minus 1.5 from this, right? So basically, if I do this, I'll get minus 2, I'll get minus 1.5, and I'll get minus 1. And you can see that these values hold because A22 is going to be minus 6 plus 2, that's going to be minus 4, and minus 4 by 2. So wait a minute, there's a mod over here. Shit, right? I didn't see them. So basically, I'll just remove these negatives, right? So for this is going to be A11, that is minus 3 plus 1, that's minus 2. But mod of minus 2 is plus 2, and plus 2 by 2 is 1. 1, 2 is basically minus 3 plus 2, that's minus 1. Because of the mod, it becomes 1, and you have 1 by 2. Here, this becomes 0, and here this is plus 1. Plus 1 by 2 is plus 0.5, right? Over here, again, we have minus 6 plus 1, that's minus 5. A mod it makes it plus 5, and 5 by 2 becomes 2.5. Over here, this is minus 6 plus 2, that's minus 4. Mod of minus 4 is 4, and 4 by 2 is 2. Here is minus 6 plus 3, that's minus 3. Mod of minus 3 is 3, 3 by 2 is 1.5. And 2, 4 becomes minus 6 plus 4, that's minus 2. Mod of minus 2 is 2, 2 by 2 is 1. Similarly, over here, this is going to be minus 9 plus 1, that's minus 8. A mod of minus 8 is 8, 8 by 2 is 4, right? And then since you are basically increasing 1 along J, you are basically decreasing half from 4 as you move further along the columns. And so this basically becomes 4, 3.5, 3, and 2.5, right? Right. So that is the matrix A for the first subpart. For the second subpart, we have Aij equaling 2i minus j. Since this is going to be an equation, I'm going to directly substitute this into the whole matrix formula, right? And so this A11 is going to be 2 minus 1, that is 1. A12 is going to be 2 minus 2, that's 0. This is going to be minus 1, and this is going to be minus 2, right? Over here, A21 is going to be 4 minus 1, that is 3, this is 2, this is 1, this is 0, right? Because as you move 1 along the columns, what you do is you are basically subtracting 1 from AI1, right? So if you have AI1, this is I, this is 1, is going to be equal to 2i minus 1, right? And AI2 is going to be AI1 minus 1 because it's 2i minus 2, right? And so as you move further along the columns, you're basically subtracting 1, subtracting 1, subtracting 1 from this, all right? And so I can basically write this as 3, 2, 1, 0. And for 3, this is going to be A31, that is going to be 6 minus 1, that's 5. And as I move along the columns, I have to basically subtract 1 from the previous column. So this is going to be 4, this is going to be 3, and this is going to be 2, right? That takes care of question number 5. Question number 6, matrix equality, right? Find the values of x, y, z for the following equations. A, part 1 states that 4, 3, x, 5 is equal to y, z, 1, 5, right? First of all, note that the constant on both sides is the same, right? If it's not the same, then this equality cannot hold, right? And if it cannot hold, then you can't find the value of x, y, z. Since these are equal, then you can basically equate these elements. You can equate these elements, and you can equate these elements, right? Therefore, x is equal to 1, y is equal to 4, z is equal to 3, right? Or you can represent it in matrix form as a column matrix x, y, z is equal to column matrix of 1, 4, 3, right? This is also a good way of representing multiple variables because this makes them more compact and easy. Right? That is the first subpart. The second subpart states that x plus y is equal to 6. 5 plus z is equal to 5. And xy is equal to 8. Right? I've basically expanded this matrix, right? And I've checked that this 2 is going to be equal to this 2. So the equality holds, and we have x plus y is 6, 5 plus z is 5, and xy is 8. Right? I'm not writing the whole matrix. So from this, at first what you get is z is equal to 0. Alright? Very trivial. For this x plus y, what you do is either you do it in trial and error, or you can basically go ahead and square it, then subtract 4xy and get x minus y. And then you use x plus y and x minus y to find x and y. Right? But over here, trial and error is going to be easy because put x is 4 and y is 2. Basically, you get 8 and you get 6. So you have x comma y being 4 comma 6, or x comma y being 6 comma 5. That is 4 comma 2. Similarly, over here, it can be either 4 comma 2 or 2 comma 4. They are not given because xy is also commutative. X plus y is also commutative, right? And so you can have 4 into 2 and 4 plus 2, or you have 2 into 4 and 2 plus whatever, right? So basically, your matrix X, Y, Z is equal to any one of either 402 or you have 204, right? That all is better. Right. That is subpart 2, right? Subpart 3. X plus y plus z is 9. Again, I've expanded the matrix directly. I'm not writing it down, right? Then you have x plus z being 5, and you have y plus z being 7, right? There's no reason why the equality shouldn't hold at first glance, so we assume that the equality holds and start solving, right? If y plus z is 7, then directly using this value over here, we get x plus 7 is 9, or x is 2. X equals 2. Sorry for that. Since x is 2, put this in this equation. You have 2 plus z going to be equal to 5, or z is equal to 8. Z is equal to 3. Right? Using this over here, we get y is equal to 4. Right? Therefore, the solution set is x, y, z is going to be equal to, this is 2, 4, 3. That is the third subpart taken care of. Right? So we have question number 7. Find the value of a. Alright. So since we don't have any irregularities at first glance, we assume that the equality holds. And then we say that a minus b is equal to minus 1. We say that 2 times a plus c is going to be equal to 5. We say that 2 times a minus b is going to be equal to 0. And we say that 3c plus d is going to be equal to 13. Right? You have a minus b is minus 1. Right? And 2a minus b, using this over here, we can write 2a minus b as a plus a minus b being 0. Right? Or a plus minus 1 is going to be 0. A is equal to 1, which means that b is equal to 2. Right? And then you have 2a plus c being 5, or c is equal to 3. Right? Because 2a is basically 2, 2 plus c is 5, so c is 3. And if c is 3, then d is 4. Right? Because 3 3s are 9, 9 plus d is 13, or d is 4. So your solution set is basically a, b, c, d is equal to 1, 2, 3, and 4. Right? That takes care of 7. Question number 8. A is equal to aij of m cross n is a square matrix if m is equal to n. Right? That's basically your definition. Right? C is your answer. And I've highlighted the answer. Question number 9. Which are the given values of x and y make the following pair of matrices? So over here we have it's either 3x plus 7 is equal to 0, which means x is equal to minus 7 by 3, right? Or and we have 5 is equal to y minus 2, or y is equal to 7, right? But you also have this, right? So these two are taken from the first row. You have to apply these values of the second row to see if the equalities hold. If they do, then this is going to be your answer. If they do not, then you're going to say that an answer does not exist and these two matrices can never be equal, right? That's how you proceed. So we check in the second row, and I'm not going to draw this line because I draw this line when the question is completed. So we check that y plus 1 is equal to 8, which is true, which is because it's 7 plus 1, right? And 2 minus 3x is going to be 2 plus this one, 2 plus 7, right? Which is 9. But this is not equal to 4. So we have the fact that for the given value of x, for this value of x that we find, this does not yield 4, but it is 9, right? Therefore, these two matrices can never be equal. Equality does not. Therefore, you can't have a solution. B is your answer, right? This is going to be your answer. The number of all possible matrices of order 3 cross 3 with each entry either 0 or 1 is. So basically, for question number 10, we have a number this question. Okay, this is question number 9. And this is question number 10. Right? For a matrix of order 3 cross 3, it is basically going to have 9 elements. That is A1, 1, A1, A is going to be 2, 1. It's going to be 2, 1. This is going to be 3, 1. Then this is going to be 1, 2. This is going to be 2, 2. This is going to be 3, 2. And you have A1, 3, A2, 3, A3, 3. Right? You are given that each of these elements is either 0 or 1. So you have a binary choice, right? Since the selection of elements is basically different from for each element, right? There's no condition that if this is going to be 0, then this has to be 0, right? There's no conditions that are like that. So we are going to treat each element as an independent entity. So this is basically going to be a Bernoulli distribution of 9 trials, right? It's going to be it's going to be a Bernoulli trial. It's going to be 9 Bernoulli trials of 0 or 1, right? Head or tails, which is basically going to yield 2 power 9 outcomes, right? Because it's going to be 2 into 2 into 2 into 2 times so 9 times. That is basically 2 power 9, right? And 2 power 9 is 512. So D is going to be your answer. All right. With that, we complete exercise 3.1. Right. The next section deals with the operations on matrices, which does not include the equality, right? Because the equality is going to be a property, it's not an operation, right? So we have the different algebraic operations, matrix algebra, right? That is the addition, multiplication by scalar, difference, and the matrix multiplication, right? 4 things. First one is the addition of matrices. So if you have a matrix A is equal, if you have 2 matrices Aij and B is going to be equal to Bij, right? I'm not writing the order because it can be of arbitrary order. Wait, no, it cannot be of arbitrary order. It has to be, if this is of order m cross n, then this B has to be of order n cross n, right? Only and only then is the additional product, is the addition of 2 matrices defined, right? Your addition of order, this is going to be m cross n, is going to be equal to elements Aij plus Bij of order n plus, right? This is going to be an addition of each element ij. All right. So we basically define AV if A and B are 2 cross 3 matrices as A11 plus B11, A12 plus B12, A13 plus B13, A21 plus B21, A22 plus B22, and A23 plus B. All right. Or basically you can represent it in this form. This subscript is not necessary, but I've written it because it's going to be easier for you to recognize that only and only if A and B have the same order is this defined. All right. If you have two different orders, say A is of order 2 plus 2 and B is of order 3 plus 3. If you do A plus B, right, you'll see that B is going to be something like 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is going to be 1, 2, 3, 4, right? Wait, I'll just mark this as slashes. So where will these 4 slashes go and add to? Will they add over here? 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 Or will they add like 1 here, 1 here, 1 here, 1 here? What is it going to do? We don't really know and we can't really define it, right? So I basically leave matrix addition to be defined for 2 matrices of the same order, right? 2 different orders cannot add. You cannot add them. All right. A plus B is not defined. And this addition is going to be an example of a binary operation on the set of matrices of the same order, right? This becomes this statement actually holds meaning later when you deal with matrix sets and operations on matrix sets. Only then will this observation hold any meaning. Otherwise, it's just a note, and you can just basically take notes on it because you would have read about binary operations in functions, sets and functions. I think that's chapter 1 of them. I'm not sure. Okay. But yeah, you'll know what a binary operation is. You'll know what a set of matrices are. And if you form a set of matrices of the same order, an infinite set, you'll see that this addition of matrices is going to be a binary operation on that set. All right. Then you have multiplication by scalar. Multiplication by scalar is basically k times a, which you have already defined in the previous properties, which is basically k times a11, k times a12, dot, and k times a21, k times a22, dot, right? So basically, every element is going to be multiplied by the scalar k. That is what is multiplication of matrix by scalar, right? Similarly, if you have this form, then you can basically bring it to this form. These are both equivalent, right? Or you can write this as Ka is going to be equal to K of Aij of m cross n is equal to a matrix of K times Aij of the order m cross n, right? Or if Bij is going to be the final matrix, then Bij is equal to K times Aij for all ij, right? That is what is meant by this. This is going to be the formal representation of scalar multiplication, right? That leads to a special matrix that is a negative matrix that is going to be -1 times A, right? And then you have this leading from the sum of the matrix, that is the difference of matrices, right? If you have A plus -1 times B, that is basically equal to A minus B, right? This is what is the difference. This is going to be a sum, and this is going to be a representation of the sum property and the scalar sum operation and the scalar operation, right? Then you have matrix addition properties, that it is basically commutative, it is associative, it has an additive identity, and it has an additive inverse, right? An additive identity is going to be the zero matrix of the order m plus n, and the additive inverse is going to be minus times or minus of A. And scalar multiplication is going to have these properties. It is distributive, right? K times A plus B is going to be Ka plus Kb. This is going to be this K plus L times A is going to be Ka plus La. K times A plus B is going to be this is basically a proof of this, right? And this is a proof of this. Then you have multiplication of two matrices. In the multiplication of two matrices, what you basically do is if you have A is all Aij of the order m cross n, I'll write it as K cross L, right? And you have B equals the matrix of elements Bij of the order L cross M, right? Note that let's see be the product A cross B, right? This is going to be a matrix product or a vector product, whatever you want to call it, right? This C is going to be A cross B. It's going to be equal to matrix of elements Cij of the order K cross M, right? Know the three different orders that I've written. First one is K cross L. Second one is L cross M. And third one is K cross M, right? Note that this index and this index has to be equal for this product to be defined. If these are not equal, then this product is not defined. All right. Take very good care of this fact, because in most cases people fail to check this, and sometimes they denote a product where a product cannot exist. Right? Why this arises is because in matrix multiplication, what you do is you multiply the ith row of A with the kth column of B, and the number of elements in this row has to be equal to the number of elements in this column. Right? Only and only then can this product be defined. Right? And we basically represent Cij as the sum of all elements. This is going to be the sum over, this is going to be Aik, and this is going to be Bkj, right? Cij is, can basically be represented in this form. What this means is, it is basically the sum of A1k, this is AI1 into B1k plus AI2 into B2k plus AI3 into B3k plus whatever up till AIN into BNK. All right. This is basically this form or this form, right? Since I have subscribed IJ over here, but they have done IK over here, right? Instead of K, I'm writing J. Instead of J, I'm writing K. Don't get confused, right? And the sigma K notation is basically the sigma over all K that is allowed in this in your statement. All right. So since here your K runs from 1 to N, this can be written as a K goes from 1 to N. Okay. That is going to be your matrix multiplication. Then you have examples. Work out these examples and note that this matrix multiplication is not commutative, right? It is not commutative. I'm writing it in all caps because this is very, very important, right? This is not commutative, right? But there are some matrices for which AB equals BA, right? For example, this kind of a matrix 1002 and 3004, AB is equal to BA, which is right? Multiplication of diagonal matrices of the same order will be commutative. This does not mean that only the multiplication of diagonal matrices is commutative. It means that the multiplication of diagonal matrices is always commutative. Right? This is a one-way logic. This is not a two-way logic. Right? If AB is equal to BA, that does not mean that A and B are diagonal. It means that this states that if A and B are diagonal, then the product is going to be commutative. Then you have 0 as product of two non-zero matrices. This character, right? Because you are having a continued sum over here, and the sum can be 0 even if the individual elements are non-zero. The product of two matrices is a zero matrix. It's not necessary that one of the matrices is a zero. For this first, for the multiplication of matrices, we have associativity holding. That is ABC, AB times C is A times BC. And distribution, that is A times B plus C is AB plus AC. And A plus B times C is AC plus BC. Right? Left distribution, right distribution. Both exist. And finally, we have the existence of a multiplicative identity That is, I times A is going to be A times I is going to be A. All right. These are examples. Again, this is to go through the examples because they are actually good, and you get practice dealing with questions which have previous solutions, and you can get to know how people exercise. So that deals the info dump for exercise 3.2, and we are just going to get it right. Exercise 3.2. Let A is equal to 2, 4, 3, 2, B is equal to 1, 3, minus 2, 5. Wait, I just write this. A is going to be equal to 2, 4, 3, and 2, right? What? B is going to be equal to, this is 1, 3, minus 2, and 5, right? And C is going to be equal to minus 2, 5, 3. Okay. So in this question, we need to find several operations, the results for several operations. That is, first is A plus B. Note that in the plus operation, the order of the matrix does not change, right? First things first, check if the order of both the matrices are the same. A and B have order 2 cross 2, 2 cross 2, so the orders are same. So you have a defined sum, right? A plus B is then going to be 2 plus 1, that is 3. 4 plus 3, that is 7. Then 3 plus minus 2, that's minus 1. And 2 plus 5, that's again 7. Right? Then there's going to be the second subpart, that is A minus B. Right? That is going to be equal to, again, since you have a defined sum, you will have a defined difference, because the difference is basically the sum and a sum and a scalar operation, right? So A minus B is going to be 2 minus 1, that's 1. 4 minus 3, that's 1. 3 plus 2, that is going to be 5. And 2 minus 5, that is going to be minus 3. Right? This is your answer. This is your answer. Then you have the third subpart, that is going to be 3 times A minus C. Alright? That is going to be equal to 3 into 2, that's 6. Minus 2, that is going to be 8. This is 3 times 2, 3 times 4, that is going to be 12. 12 minus 5 is going to be 7. Then you have 3 into 3, 9, minus 3, that is 6. And 3 into 6, minus 4. This is going to be an answer. Alright? Question number 4. That is A times B. Right? What I've already told you is that AB is going to be the set of Cij such that Cij is going to be equal to sum over K of Aik into Bk, right? That means that the first element is going to be this row multiplied by this column, right? This row 2, 4 multiplied by the column 1 minus 2, right? This element, the second element, that is A12, is going to be equal to this row multiplied by this column. And similarly, the third element is going to be 3, 2 multiplied by 1 minus 2. And the fourth element is going to be 3, 2 multiplied by 3 and 5, right? So we have the first element to be 2 into 1, that is 2, minus 4 into 2, that is 8. The second element is going to be 6 plus 20. The third element is going to be 3 minus 4. And the fourth element is going to be 3 into 3, 9, plus 2 into 5, 10. Right? Which is basically minus 6, minus 1, 26, and 19. That is going to be your answer. And lastly, question number 5, that is B times A. Right? Again, it's going to be 1, 3 into 2 minus 2, 3. That is going to be 2 plus 9. This is going to be 1, 3 into 4, 2. That is going to be 4 plus 6. This is going to be minus 4 plus 15. And here it is going to be minus 8 plus 10, which is equal to 11, 11, 10, 2. Right? And here you can see that BA is not equal to AB. It's not equal to. Right? Now going to question number 2. Come with the following. That is AB plus AB minus BA plus AB BA. I'm going to directly write the answer, right? Because this is a very trivial sum. Everybody should know this. This is basically 2A, 2B. Here is a 2A and here is a 0. Right? This is going to be your answer. Right? The second question again is going to be trivial. This is A square plus 2AB plus B square. That is going to be equal to A plus B the whole square. This is going to be B plus C the whole square. This is going to be equal to A minus C the whole square. And this is going to be equal to A minus B the whole square. Right? Because this is A square minus 2AC plus C square. This is A square minus 2AB plus C square. Right. Then third subpart. This is going to be a 3 cross 3 matrix. Right? This is going to be minus 1 plus 12, that's 11. This is going to be 7 plus 4, that is 11. This is going to be 6 minus 6, that is 0. Right? This is going to be 8 plus 8, 16. This is going to be 5 plus 0, 5. This is going to be 16 plus 5, that is 21. And this is going to be 2 plus 3, that is 5. This is going to be 8 plus 2, that is 10. This is going to be 5 plus 4, that is going to be your answer. Right? And finally, the fourth question, that is cos square x plus this, right? This whole thing. First of all, know that the orders are same. Second, this plus this, this plus this, this plus this, this plus this, right? Know that everything is going to be cos square plus sin square plus cos square plus cos square, and cos square plus sin square. And so everything is going to be equal to 1. Because sin square plus cos square is 1. That is simple. Question number 3. Compute the indicated products. 1. AB minus BA, A minus BB. Basically, you have AB, you have minus BA, then we have A minus B and BA. Right? First things first, your A11 is going to be equal to this vector multiplied with this vector, right? So it is going to be equal to A squared plus B squared, right? Then A12 is going to be this multiplied with this, that is minus AB plus AB, that is going to be 0. Similarly, A21 is going to be 0, right? And A22 is going to be equal to A squared plus B squared. Right, because it's going to be minus BA times AB, that is going to be minus AB plus AB, that is 0 over here. And over here is going to be minus B times minus B, that's B squared. And this under this, that's A squared. So it's going to be A squared plus B squared. So your matrix A, which is a product, is basically going to be A squared plus B squared. This is 0, this is 0, this is A squared plus B squared. Right? Everybody will be perfectly happy if you do this, but you can go one step further and write this as A squared plus B squared times I2. Right? Question number 2. This is a column 1, 2, 3 multiplied by a row. This is 2, 3, and 4. Right? First of all, know that the order of a column matrix is basically 3 cross 1, and that of a row matrix is 1 cross 3. Right? Know that this index and this index are equal. So you will have finally a product matrix of order 3 cross 3, right? And that is going to be filled with a row in a column of each element, that is going to be 2, 3, and 4 because it's a multiplication by 1. Then this is going to be multiplied twice, that is 4, 6, and 8. This is going to be multiplied thrice over here, that is 6, 9, and 12. Right? That is going to be your final matrix. Question number 3. This is going to be 1 minus 2, this is 2, 3, into 1, 2, 3 by 2, 3, 1. Right? This is 2 cross 2. Know that this is 2 cross 3 and this index is equal to this index. So basically, you'll have a final matrix of the order 2 cross 3, right? Which means that you're basically going to have, this is 1 minus 4, then this is 2 minus 6, this is 3 minus 2, and this is going to be 2 plus 6, this is going to be 4 plus 9, and this is going to be 2 into 3, 6 plus 3, which is basically minus 3, minus 4, 1, 8, 13, and 9. This is going to be your answer, right? Then you have question number 4, which is a 3 cross 3 into 3 cross 3 matrix, right? We all know that the answer again is going to be a 3 cross 3 matrix because the two other indices are going to be 3 and 3 respectively. Right? Just give me a moment. So we have two matrices, that is 2, 3, 4. This is 3, 4, 5, and this is 4, 5, 6 into 1 minus 3, 5, 0, 2, 4, 3, 0, 5. Right? Your multiplicative answer is going to be a 3 cross 3 matrix of, I'm going to write the whole calculation, right? So don't worry, this will be 2 minus 9 plus 20. Wait, I'm sorry. This is going to be 2, 3, 4 into 1, 0, 3. That is 2 plus 0 plus 12. Then you'll have 2, 3, 4 into minus 3, 2, 0. That is going to be minus 6 plus 6 plus 0. I'm not adding the 0. And then you'll have 2, 3, 4 into 5, 4, 5. That is going to be 10 plus 12 plus 20. Right? And then you'll have 3, 4, 5 into this. That is going to be 3 plus 5, these are 15. Right? Then you'll have 3 into minus 3. That is going to be minus 9 plus 8. Then you'll have 15 plus 16 plus 25. Right? And finally over here you'll have 4 plus 18. You will have 4 into minus 3 as minus 12 plus 10. And you will have 20 plus 20 plus 30. Right? Which is basically equal to, take us the matrix 14, 0, 42. Then you will have 18 minus 1, and then this is what, 40, 56, right? 56, and you will have 22, you will have minus 2, and you will have 70. This is a equal product. And there are 22 questions. Wow. All right. Going to question number 5. Right? You will have 2, 1, you will have 3, 2, you will have minus 1, 1, into, you have 1 minus 1, you have 0, 2, and you have 1, 1. Right? This is 3 cross 2, and this is 2 cross 3. So you'll be left with a matrix of 3 cross 3, right? Because this and this are the same. That's the first thing. So what you do is, you basically make A is equal to, take us a matrix, a huge matrix, right? A 3 cross 3 matrix of elements. This is going to be 2 minus 1. This is going to be 0 plus 2. This is going to be 2 plus 1. This is going to be 3 minus 2. This is going to be 0 plus 4. And this is going to be 3 plus 2. And finally, this is going to be minus 1, minus 1. This is going to be 2. And this is going to be minus 1 plus 1. Which is basically equal to 1, 1 minus 2. 2, 4, 2, 3, 5, 0. That is your answer, right? Finally, going to question number 6, right? This is 3 minus 1, minus 1, 0, 3, 2, times, this is 2 minus 3, this is 1, 0, and this is 3, 1. Right. This is the case. This is going to be 2 cross 3 into 3 cross 2. Basically, your resultant matrix is going to be 2, 2 because 3 and 3 are equal. Right. So we have A is equal to a 2 cross 2 matrix of elements. This is going to be 6 minus 1 plus 9. This is going to be minus 9 plus 3. Right, because minus 1 is 0, 0, I'm not adding zeros. And over here is going to be minus 2 plus 6, and it is going to be 3 plus 2, which is equal to, this is 14, this is minus 6, this is 4, and this is 5. This is going to be 5 now, right? This is 14. I'll just write this properly. This is going to be 14, this is going to be minus 6, this is going to be 4, and this is going to be 5. Right. That is question number 3. Question number 4. A is this, B is this, C is this. Compute A plus B and B minus C. Verify that A plus B minus C is equal to A plus B minus C. Alright. So we have, I'm just directly summing another question without writing the given data out. Do not do this, but over here I'm just too lazy to do it. Right. So it's going to be A plus B. You have to compute. That is equal to, since both are 3 cross 3 matrices, this is also 3 cross 3 matrix and it exists. So we have, and it is defined. So we have A plus B being 1 plus 3, that is 4. We have 2 minus 1, that is 1. And then you have minus 3 plus 2, that is minus 1. You have 5 plus 4, that's 9. You have 0 plus 2, that's 2. And you have 2 plus 5, that is 7. And finally, you have 1 plus 2, that's 3. You have minus 1 plus 0, that's minus 1. And you have 1 plus 3, that is 4. Right? A plus B is 4, 1 minus 1, 9 to 7, 3 minus 1, 4. All right. And then you have B minus C. Again, it's a trivial operation. And this is going to be minus 1. This is going to be minus 2. This is going to be 0. This is going to be 4. This is going to be minus 1. This is going to be 3. And this is going to be 1. This. All right. Funny thing, note that the determinant of this matrix is going to be 0 because this row is an exact negative of this row. Right? That's neither here nor there. So we have this to be, this matrix to be A minus C, this matrix to be A plus B. All right. You have to verify that A plus B minus C is equal to A plus B minus C. All right. So let this be K, let this be L. Right? Now, A plus K is going to be, again, it's going to be 3 cross 3 matrix because both the entities here are 3 cross 3 matrices. And so A plus K is going to be 1 plus minus 1, that is 0. 2 plus minus 2, that is 0. Minus 3 plus 0, that is minus 3. Then you have 5 plus 4, that's 9. You have 0 minus 1, that's minus 1. You have 2 plus 3, that is 5. And finally, you have 1 plus 1, 2. 2 minus 1 is 1. And 1 plus 0. So you'll have this to be A plus K. And L minus C is going to be equal to, again, since both the entities are 3 cross matrices, they'll have 3 cross matrix as the answer. Right? L is going to be 4, 1 minus 1, 9 to 7, 3 minus 1, 4. And that minus C is going to be equal to 4 minus 4 is 0. 1 minus 1 is 0. And then it's going to be L minus C, right? So it is going to be L, that is minus 1, minus 2. That is going to be minus. Similarly, over here you have 9 to 7 and this 0, 3, 2. So I'm going to basically write this as 9, minus 1 and 5. And finally you have 1 minus 2, 3 over here. You have 1, 2, 0 over here. So it is basically 0, 0 plus 4 is what? This is minus 2. This is going to be minus 1, right? Oh, this is going to be minus 1. This is going to be minus 2. So it's going to be minus 1 plus 2. That is plus 1. It's not 4. This is plus 1. and where 4. And this is 1, this is 3, 3 minus 1 is not 0, it is 2, right? And so you can see that these both matrices are the same. And so this is verified because A plus K is basically this, and L minus C is basically this. And LHS is equal to RHS and we have proved it. So we have verified, right? Question number 5. If this and this, then compute 3 times A minus 5 times B. Alright. So 3 times A, 3A is going to be this matrix, that is 2, 3, 5, then 1, 2, and 4, then 7, 6, and 2. Alright. And 5 times B is going to be the matrix. 5 times B is going to be the matrix 2, 3, 5, 1, 2, 4, 7, 6, which is basically equal to 3. Therefore, 3A minus 5B is going to be equal to 0. Right? It's actually going to be equal to O3, that is 0 matrix of order 3. Right? Because 3A minus 5B is going to be a matrix of elements of 9 0 elements in the form of a square matrix. Alright. And so you have 3A minus 5B being O3. That is the 0 matrix of order 3. And now going to the 6th question. Simplify cos theta into this plus sin theta into this. So basically, here let the expression E equal cos theta into cos theta sin theta minus sin theta and cos theta plus sin theta into, this is going to be sin theta minus cos theta and sin theta, right? Which is equal to the matrix of, this is cos square theta plus sin square theta. I'm skipping 2 steps. That is, one is the multiplication of this inside, one is multiplication of this inside, and the addition operation, right? I'm just combining directly into one step. This is going to be cos theta sin theta minus sin theta cos theta. This is going to be 0. Similarly, over here is going to be 0 because it's minus cos theta sin theta. This is going to be plus sin theta cos theta. And over here, you will again have, this is cos square theta plus sin square theta, right? This is basically matrix of, this is the matrix 1, 0, 0, 1, right? Which is identity of element 2, of order 2, not element. Question number 7. Find x and y if x plus y is this matrix and x minus y is this matrix. So we have x plus y being 7, 0, 2, 5 and x, wait, I'll write this below this, and x minus y being 3, 0, 0, 3, right? Adding these two equations, what we get is 2x equaling, this is 10, this is 0, this is 2, this is 8. Or x is equal to, this is 4, 1, wait, this is 5, 1, 4, 0. Right, this is what is x. And from x, finding y is going to be very simple. Y is basically this minus x, which is 7 minus 5 is, since it's going to be 2 cross 2, you'll have a 2 cross 2y. 7 minus 5 is 2, 0 minus 0 is 0. And then you have 2 minus 1 and 5 minus 4, right? That both are basically 1. So you have x is 5014 and y is 201. right? That gives us 7.1, 7.2, which states that, wait, this is part 1, right? Which states that 2x plus 3y is equal to, this is going to be, 2340. And you have 3x plus 2y is going to be equal to 2 minus 2 minus 1, 5, right? Multiply this by 3, multiply this by 2, you basically get, and then subtract both, right? You basically get 9 minus 4, that is 5 times y, is equal to 3 times 2 minus 2 times 2, that is equal to 2, right? Then you have 3 into 3, 9, plus 2 into 2, 4, that is going to be 13. Over here you have 3 into 4, 12. You have 2 into minus 1, that's minus 2. Since there's a minus, it's going to become 12 plus 2, that's 14. And this 0 is going to be 2 into 5, that's 10, right? And there's a minus. So this is going to be 5 times y. Wait, yeah, this is going to be 5 times y. So y is going to be basically 2 by 5, 13 by 5, 14 by 5, and minus 2. Thus, x is going to be equal to half of this matrix, that is 2, 3, 4, 0, minus 3 times y, right? That is going to be 2 minus 6 by 5, that is 4 by 5. This is going to be what? 3 minus 39 by 5, that is going to be minus 24 by 5. Sorry for that. There was a little discussion in the mic. Right. This is 4 by 5. This is going to be minus 24 by 5. And then you have 4 minus 3 into 14 by 5. That's 4 minus 42. That is minus 22 by 5. And you have this 0 minus 2. Right. That is 0 minus of minus 2. Minus 6. That is plus 6. So we're going to basically have this to be 2 by 5. This is going to be minus 12 by 5. This is going to be minus 11 by 5. And this is going to be plus 3. This is what is x. This is what is 5. Note that everywhere over here I've used the square brackets, but here I've used the parentheses. Right? It's not matter what brackets you use, it just matters that you use a bracket. Okay. Both of these are valid forms of representing a matrix. Don't get confused. Right? You can represent it either way, whichever way is easy for you. Nobody is going there. Question number 8. Find x if y is this, and 2x plus y is going to be this. So we have 2x is equal to this minus y. That is going to be 1 minus 3, that is minus 2. This is 0 minus 2, that is minus 2. This is minus 3 minus 1, that is minus 4. And 2 minus 4, that is again. Therefore, when you do 1 by 2 over here, you have x is equal to minus 1, minus 1, minus 2, plus minus 1. And there is the answer. Right. This is going to be question number 8. Question number 9. Find x and y. This plus this is equal to this. So basically, 1 plus y is going to be equal to 5. Over here, we have 3 plus 0. That is equal to 6. Wait, no, this is 2 into this, right? So this is going to be 2 plus 5. Let's just say this. 2 plus y is 5. And then 2 into 3 is 6 plus 0 is 6. 2 into 0, 0 plus 1 is 1. And 2x plus 2 is equal to 18. Right? From here, you get that y is equal to 3. From here, you get that 2x is equal to 16 or x is equal to 8. right? So you have the matrix XY is equal to 8, 3. That is question number 9. Wait a second. Wait a second. Wait a second. This is going to be 2x plus 2 is equal to 8. This one 18. Why did I just say 18? Really sorry for that. So this is going to be x is equal to, this is 6 by 2, that is 3. Right? So this is not 8, but this is also going to be 3. That is your answer. Question number 10. Solve the equation for x, y, z, and t if 2 into this plus 3 into this is equal to 3 times this. So basically what happens here is that I'm going to separate this to 4 equations. That is 2x plus 3 is equal to 9. You have 2z minus 3 is equal to 15. You have 2y plus 0, that is 2y, is equal to 3 into 4, that's 12. And then you have 2t is equal to, this is 2t plus 6 is equal to 18, right? So this and this goes, you have 12 remaining over here. This and this goes, you have 18 remaining over here. This and this goes, you have 6 remaining over here. Therefore, we have a matrix x, y, z, t, and over here 2x is 6. So basically, we have the different values, that is x is 3. You have y, 2y is 12, y is 6. You have z equals 18, 2z is 18, z is 9. And then you have t, again that is 2d equals 12, or t equals 6. Right? Right. That's your answer. Question number 11. X times 2, 3 plus y times minus 1, 1 is 10 and 5. Find the values of x and y. So basically what this is, what this linear equation is 2x minus y is equal to 10. You have 3x plus y equal to 5. Add these both, you basically get 5x is equal to 15, for x is equal to 3. So you have this being what? So you have this being x equals 3, right? And then because x is equal to 3, you can basically substitute this over here and say that y is equal to 6 minus 10, that's minus 1, right? 3 3s are 9 minus 4 is 5. So this checks out, and your solution set xy is going to be equal to 3 and minus 4. Then question number 12. Given 3 times x y z w is equal to blah blah blah, then find the values of x y z w. Alright, so we have, I'm not writing the matrix, I'm just writing the exponent forms again. So we have 3x is equal to x plus 4. We have 3y is equal to 6 plus x plus y. We have 3z equaling minus 1 plus z plus w, and 3w being minus 1 with being 2w plus 3, right? This means the w, so basically if the solution set is going to be x, y, z, w, then we can basically write this as something, 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 and this is going to be 3, because you have 3w is equal to 2w plus 3, and the 2w goes from 3w leaving 1w, and that gives us w equals, right? Similarly, from the first statement, I can say that 2x is equal to 4, or x is equal to 2. Right? From this statement, I can say that 2y is equal to 6 plus x or 6 plus 2. So 2y is equal to 8 or y is equal to 4. And finally, over here, you have 3 plus z being 2 plus z. Okay, this 3z minus z being 2z. I don't know where the plus came from. Sorry. Right? 2z being minus 1 plus w. Since w is 3, that means that 2z is equal to 3 minus 1, that's 2. And so z is equal to 1. Therefore, this is the solution set 2413 for x, y, z, w. So I will not, I'll just write the detailed expressions. From here, you have w is equal to 3. From here, you have 2x is equal to 4, which leads to x. From here, you have 2y is equal to 6 plus x, which is 8, substituting x equals 2. And so y is equal to 8 by 2, that is 4. Y is equal to 4, y is equal to 8 by 2, that is 4. Right? And finally, this is going to be 2z equaling minus 1 plus w, which is 2z acting like 2z minus 1 plus 3, which is 2 into z equaling 2 or z equaling 1. Right? That is question number 12. Wow. Question number 13. If fx is this, show that fx times fy is equal to f of x plus 5. So I'll just write the LHS fx times fy. Right? This is equal to, this is a matrix product, right? Because fx is a matrix. Cos x minus sin x 0, sin x cos x 0, 0, 0, 1. Perfect. Into, this is going to be fy, that is cos y, this is going to be sin y, and this is 0, this is minus sin y, here is a 0, this is a cos y, this is a 0, this is a 0, this is a 1. So, using your normal matrix multiplication rules, again, the product is going to be 3 plus 3 matrix because there are 9 elements, 3 plus 3 over here and over here, right? And so you are going to basically have, in this first place, this row into this column, that is cos x, cos y, minus sin x, sin y, plus 0. Then in the second place, you have this row into this column, that is minus cos x sin y plus sin x cos y, and you have a 0, right? Because this is going to be 0 in the cos is going to be 0, 0, minus sin x is going to be 0, 0, and you have 0 into 1, 0. Similarly, over here, you will have this row into this column, that is basically sin x cos y plus cos x sin y. Right? Over here, again, it is going to be this row into this row, that is cos x cos y minus sin x sin y. And again, is a 0 because this one is 0, 0, this one is 0, 0, this one is 0, this one is 0 and 1 is also 0. Right? Finally, you have 0, 0, 1 that yields you a 0 over here, a 0 over here, and a 1 over here. Right? Which is basically just using the formula of cos of A plus B, that is cos A cos B minus sin A sin B. I can write this as cos of x plus y, right? Here it is sin x cos y minus cos x sin y. So this is sine of x minus y. Wait a second. Wait a second. Wait a second. This one plus here. This is also a minus. Very sorry for that. Very sorry for that. This is going to be sine of x plus y and a minus outside, because it's going to be minus of sin x cos y plus cos x sin, right? And this is 0. This is going to be sine of x plus y. This is again going to be cos of x plus y. This is 0. This is 0, 0, and this is 1. Which is basically f of x plus y, right? Which is RHS. Therefore, true. Right? Because the capital F function is the matrix of cos x sin x 0 minus sin x cos x 0 and 0, 0, 1. Okay. So we have shown that the LHS is equal to the RHS. That completes 20 to 14. Show that 1, 5 minus 1, 6, 7 to 1, this is not equal to. Show that the multiplication of this is not committed, right? So first things, in part 1, I'll take the LHS first for this, right? You have 5 minus 1, you have 6, 7, into you have 2, 1, and you have 3, 4, right? This is following the matrix multiplication rule. This is again a 2 cross 2 product, right? Of this row, this column, that is 5 into 10 minus 3 is 7. This is 5 minus 4 is 1. You have 6 2s are 12 plus 21, that is 33. And then you have 6 plus 28, that is 34, right? The RHS, on the other hand, is going to be 2, 1, 3, 4 times 5 minus 1 and 6, 7. That is equal to, again, following the same rules, is going to be 2 cross 2 product of 10 plus 6 is 16. You have 3 5 is 15 plus 24, that is 39. You have 2 minus 2 plus 7, that is 5. And you have minus 3 plus 28, that is 25. Right? You can see that these both are not equal, right? Wait a minute. These both are not equal. So we have basically proved that LHS is not equal to the RHS. This is what is asked for in the question. Therefore, verified. Prove that this is not equal to this. Again, commutativity of a third order matrix. All right, so we have on the LHS, again, I'm writing L for LHS and R for RHS, right? On the LHS, we have 1, 2, 3, 0, 1, 0, and 1, 1, 0 times minus 1, 1, 0, 0, minus 1, 1, 2, 3, 4. All right. So following the rules of matrix multiplication, again, this is going to be a degree 3 matrix, an order 3 matrix, where the first element is going to be this row into this row, this column, that is minus 1 plus 6, that is 5. Then you have 1 minus 2 plus 9, that is going to be 8. And then you have 0 plus 2 plus 12, that is 14. Right? Over here is going to be 0. It is going to be minus 1. It is going to be plus 1. And then over here, it is going to be minus 1. It is going to be 0. And over here is going to be 1. Right? By 14, 0 minus 1, 1. And minus 1, 0, 1. Right? On the RHS, on the other hand, you have the exact opposite, the commutative reverse of this, right? Which I'm basically doing straight out from here. write the matrix sum, wait, the matrix product PR is going to be equal to, again, a third order matrix. So we have this into this, that is basically -1, 0 and 0. This is -1, right? This is going to be -2, 1, 0. That is again -1. And over here is going to be -3, 0, 0. That is going to be -3. Right? Then you will have 0, -1, -1 into all this. That is going to be, over here it's a 1. Over here is a 0. And over here is a 0. Finally, you will have 2 plus 4, that is 6. You will have 2 into 2, that's 4 plus 3 plus 4, that is going to be 11. And you have 2 into 3, that is again 6. Right? And you can basically see that these both are not equal. Therefore, LHS is not equal to RHS. Therefore, prove. That is question number 14. Going to question number 15. Find a squared minus 5a plus 6i if a is this. All right. So first things first, right. Now, just look at the fact that over here, A is a 3 plus A matrix, right? They haven't given what I is. In these types of questions, you can basically assume I to be of the order of A. Cool. So basically over here, I is I3, right? A squared is A times A, which is 201, 213, 1 minus 10 times itself, right? So I'll just write this down, 201, 213, 1 minus 10 times 201, 213, 1 minus 10, right? Which is basically a 3 cross matrix of, this is 2 into 2, 4 plus 1 is 5. This is 0, 0, minus 1. This is 2, 0, 0. And then you have 2 2s are 4 plus 2, 6 plus 3, 9. You have 2, 0 plus 1 minus 3 is minus 2. And you have 2 1s are 2 plus 3, 5. And finally, you have 2 minus 2, 0 plus 0 is 0. You have 0 minus 1, 0. And you have 1 minus 3, that's minus 2. Okay. And so you have A squared being 5 minus 1, 2, 9 to minus 9 minus 2, 5, and 0 minus 1 minus 2. Right. Therefore, your expression A squared minus 5A plus 6I is basically equal to the matrix of 5 minus 5 times of A, that is basically 5 into 2, that's 10. 5 minus, this is 5 minus 10 plus 6. Here it is going to be minus 1 minus 0, that is minus 1, right? And you have over here 2 minus, this is 5 times of 1, that is 5, right? Over here it is going to be 9 minus 10. This is going to be 1, wait, this is going to be minus 2 minus 5 plus 6. Then over here it is going to be 3, wait, this is going to be 5 minus 15. And finally, over here it is going to be 0 minus 5. It is going to be minus 1 plus 5. And here it is going to be minus 2 plus 6, which is basically, this is 5 plus 6, 11 minus 10, 1. This is 1. This is minus 1. This is minus 3. This is minus 1. This is again minus 1. And this is minus 10. This is minus 5. This is minus, this is plus 4. And this is again plus 4. So your answer is 1 minus 1 minus 3, minus 1 minus 1 minus 10, and minus 5, 4, 4. This is your answer. Question number 16. Wow. If A is 102, 021, 203, prove that this is 0. Right. First things first, note that you cannot factorize this into A minus 2i into A minus 3i and do it. All right. You can't do that. I'll let you find out why, and I'll let you figure out if you can do that and when you can do that. But generally, you should not rely on that method to find out what the final answer is. All right, just saying that. That's a note. So over here, again, we are going to deal with a squared being a into a. That is just multiplying this with itself. Okay, fine. So this is going to be 102 times 102. That is going to be 5. Here it's 102 times 020. That is going to be 0. And this is 102 times 213. That is 2 plus 6. That is 8. Right? Here it is going to be 021 into 102. That is 2. This is again going to be for 2 into 2. That's 4. And this is going to be 0 into 2, 2 into 1, 1 into 3. That's 5. Right? Finally, you have 203 times 102. That is 2 plus 6, 8. You have this is 0. And here it is going to be 2 2s are 4, 3 3s are 9. That's going to be 13. Right. A cube, the same way, is going to be this times this. That is 508 into 102. That is going to be 5 plus 8 to the 16. That's 21. Then it is going to be a 0. Right. And similarly, the last row is going to have a middle 0. And then you're going to have 5 2s are 10, 8 3s are 24. That's going to be 34. Right. Over here is going to be 245 times 102. That's 2 plus 10 is 12. Over here is going to be 8 plus 26. That is again 34. Right. Here it is going to be 245 times 020. That is going to be 8. And then you're going to have 2 into 4 plus 4, 8 plus 15. That's going to be 23. Finally, you have 8013 into 213. That is going to be 16 plus 39. That is going to be A5. This is A cube. This is A squared. Therefore, your equation A cube minus 6A squared plus 7A plus 2Y is going to be equal to the matrix of, this is going to be I3, all right, because we have a 3 plus a matrix. So this is going to be equal to this basically A cube, that is 21, minus 6 times of A squared, that is 30, plus 7 times that of A, that is plus 7, plus 2. Then you have 0, 0, 0 and 0. This is 0, right? And then you have A cube minus 6A squared, that is going to be 6 is a 48, plus 7 times that and 8, that is 14. And I is of course 0, right? Then you have the middle digits. This is going to be A cube, that is 12, minus 6 2s are 12. Then you have the middle digit, that is going to be 8, minus 4 6 are 24, plus 7 times 2, that is going to be plus 14, plus 2, right? And finally, you have 23, minus 6 times 5, that is 30, plus 7, because it's 7 times 1. And then I3 is going to have a 0 there, right? And finally, coming to the last stretch, that is going to be 34, minus 6 8s are 48, plus 7 times 2, that is 14. You're going to have a 0 over here. And then you're going to have 55, minus 13 6 are 78, plus 7 into 3, that's going to be 21, plus 2. Right. Look here, Now 7 plus 2 is 9. 9 plus 21 is 30. And 30 minus 30, this becomes 0. Right? 34 plus 14 is 48. And this minus 48, this becomes 0. 12 minus 12 is 0. This is 8 plus 14, that's 22. 22 plus 2 is 24. And 24 minus 24, 0. Again, 23 plus 7 is 30. 30 minus 30 is 0. Right? Similarly, this is again 0. This is 25 plus 21, that's 76. Plus 2 is 78. Minus 78 from 0. Therefore, this whole thing is equal to O3. That is the 0 matrix. And that is what they've asked us to do. Therefore, have to do. Right? That ends question number 16. 17. If A is 3 minus 2, 4 minus 2, and I is 1, 0, 0, 1, find K so that A squared is Ka minus 2i. Alright, so we have A squared being A times A, that is 3 minus 2 into 3 minus 3, 4, which is 3 times 3, that's 9 minus 8. That is, I'll just write 1 over here. This is going to be 3 into minus 2, that's minus 6, plus 4, that is going to be minus 2. This is going to be 4 times 4 into 3, that's 12, minus 8, that is going to be 4. And here is minus 8 plus 4, that is minus 4. Alright. So we have A squared is 1 minus 2 and 4 minus 2. Right. So A squared plus 2y then is going to be equal to, this is 3 minus 2, 4 minus 2. Right? Which is equal to A. Therefore, over here, the equation is A squared is equal to K minus 2y. Therefore, A squared is equal to A minus 2y. Right? Because here I is equal to I2. Therefore, K is equal to 1. It's not I, this is 1. Alright, this is 1. Right. Question number 18. If A is 0 minus tan alpha by 2, tan alpha by 2 0, and I is the identity matrix of order 2, show that I plus A is tan minus A into cos alpha minus sin alpha cos alpha. Right. What I can do over here is basically use the half angle formula to prove this. Right. What I can use is the half angle formula. Right. Note that tan of alpha by 2 is going to be equal to 1 minus cos x divided by sin x. Right? Note this down. So you can use either this or you can use something else to prove this whole thing. But I'll just try using this now. So take your RHS, right? I minus A is the matrix 1 minus wait, this is 1 plus tan alpha, right? This is 1 tan of alpha by 2. This is minus tan alpha by 2. These are the minus over here. And this is going to be 1. This is not x, this is going to be alpha, right? Because I've used an alpha on the left-hand side. So I minus A is this. So we have RHS being equal to your 1. I'll just substitute for tan alpha by 2. This is 1 minus cos alpha by, wait, instead of doing this, I'll do it at the last. Right, 1 tan alpha by 2 minus tan alpha by 2, 1 times, this is cos minus sine and cos, right? Which is basically cos alpha plus 1 minus cos alpha into sin alpha by sin alpha, right? Because this into this is your first element, right? And I'm substituting 1 minus cos alpha by sin alpha for tan alpha by 2. right? And then this is going to be minus sine alpha plus tan alpha into 1 minus cos alpha. Wait, this is not tan alpha, this is cot alpha, right? This is going to be cos alpha divided by sine alpha. Let this be over here. And then over here, it is going to be cos alpha times cos alpha minus 1 plus sine alpha. This divided by sine alpha. And then over here, it is going to be sine alpha into tan alpha by 2. That is 1 minus cos alpha into sine alpha by sine alpha plus cos alpha, right? Over here, this is going to be 1 minus cos alpha, and the cos alpha is going to go off, right? So this is going to be equal to, this is 1, and this is going to be, if I just rationalize this is going to be minus, wait, this is going to be cos alpha. It's going to be cos alpha plus, wait, this minus sine squared alpha plus cos squared alpha divided by sine alpha, right? And over here there's a 1. Over here there is again a minus cos alpha plus this whole thing, that is sine squared alpha plus cos squared alpha divided by sine alpha, right? Again, I just write this properly, right? This sine squared alpha. This is cos squared alpha, right? And this is minus cos alpha. We all know that sine squared plus cos squared is 1. So this is basically 1 cos alpha minus 1 by sine alpha. This is 1 minus cos alpha by sine alpha and 1, right? Which is basically, again, reapplying this formula over here, right? Wait a minute. Reapplying this formula over here, reapplying this formula, what I get over here is 1 minus tan of alpha by 2. Wait, this is plus tan, right? This is plus tan alpha by 2. I have a minus tan alpha by 2 over here. And I have a 1 over here, right? Which is basically I plus A, which is my LHS. Therefore, proved, right? Because LHS equals RHS. You can also do it without the formula, but if you do it without the formula, then you'll basically have a bigger equation to hand. But they all cancel out in the end, nobody's. So yeah, you'll just have to use the half angle formula for sine instead of for tan, right? Just remember this. This is a very useful formula. You'll also use this in some place else, like if you're going to go into JEE, then you'll be JEE or NEET, of course. Then wait, not NEET. If you're going to go into JEE, you'll be using this formula in solution of triangles, where you may get some half angle formulas, and you'll have to you'll have to make the substitution. Right? That's a very useful formula for that. Tan of A by 2 is going to be equal to 1 minus cos A by sine. Question number 19. Last 3 questions. A trust fund has 30,000 that must be invested in 2 different types of bonds, right? The first bond pays 5% interest per year. This is 30K, right? The first bond pays 5% per year, and the second bond pays 7% per year, right? I'm just writing the whole amount as P, writing the 2 rates as R1 and R2, right? Using matrix multiplication, determine how to divide 30K among the 2 types of bonds. If the trust fund must obtain an annual total interest of A, 1800 and B, 1000, right? Now, I'll just write the formula for the interest. Interest is basically over here, right? Interest is basically, since it's a bond, you're going to have a simple interest. So your interest is going to be P times R, right? So if you are investing X over here, then you are investing 30,000 minus X over here, right? And so you'll basically have your interest being a singleton matrix, that is 5x by 100 plus 7 into 30,000 minus x by 100, right? Given that your investment matrix P dash is going to be x 30,000 minus x, right? This is for type 1, this is for type 2, right? And your rate matrix R dash is going to be 5 by 100 and 7 by 100, right? I'm representing the principal amounts, that is the invested amounts, as a row matrix, and the rate as a column matrix, because only and only then can I get interest as P dash into R dash, right? This is why I represented this as the row, this is column, because this is 1 cross 2, this is going to be 2 cross 1, and I can have only one interest because the interest is going to be cumulative. All right. So this is going to be my interest. This is going to be the expression of my interest. In part A, I have that I is equal to 1,800. This means that 5x by 100 plus this is basically 7 into 300, that's 2100, right? Minus 7x by 100 is going to be equal to 1,800, right? Or this goes and we have 2x by 100 left. It says that 2x by 100 is equal to 300, right? Therefore, 2x is 30,000 or x is 15,000, right? Therefore, to get an interest of 1,800 rupees, you will have to have an investment matrix of 15,000 and 15,000 respective, right? You have to invest 15,000 rupees in type 1 and you have to invest 15,000 rupees in type 2. So your investment INV in type 1 in bond 1 is equal to rupees 15,000 only, and investment in the second bond is going to be equal to is 15,000 only, right? Again, this is 15,000. This is not some random string that I just made up. 15000. Why is it that? B, to get an interest of 2,000, right? The simplified thing from before says that 2,100 minus 2x by 100 is going to be equal to I, that is 2,000, right? Which means that over here, 2x divided by 100 is going to be equal to 100, right? Because it's going to be 2,100 minus 2,000. Therefore, x is equal to 10k divided by 2, that is equal to 5k, right? Therefore, your investment this matrix is going to be 5,000, and wait, you have 30k, right? Then you have, this is 25,000. Therefore, the investment INB in bond 1 is equal to rupees 5,000 only. Investment in bond 2 is equal to is 25,000, right? That is question number 9.